All right, great. All right, so uh, to us, to those people, to those people who just came in, who just started the video, uh, welcome to today's workshop, assignment workshop. Okay, cool. So let's get started by taking a look at the assignment. I'm going to assume before we start here that you've read this assignment, so I'm going to quickly skim through it. All right, so we're gonna start here with the desktop class. All right, and we're actually going to just notice that a lot of these classes are like very similar to the ones from assignment one. Okay, so it's probably more useful to just look at the differences. Okay, so we'll take a look at the differences here. So hopefully you guys can see my iPad here. So I'll scroll down and I'll start here, making a little legend for you guys. All right, so let's see. Double the price. If we take a look at the one that, if we take a look at desktop from last time. All right, so desktop class. So the price was new, right? The price is new, but it doesn't take any new skills from last time to make a new variable like that, right? So uh, just right, so this is new, but you probably know how to do that, right? The next is going to be a quantity, so two new integers. These are new. And then the CPU speed is old, and so is the RAM, so is the SSD, and the storage, right? So these are all the same. All right. And then we have a new string here called profile. So that's new. All right. So you can see the variables pretty much almost the same. I mean, we did double the number of variables, I guess, but it's pretty simple so far. Next, we have a constructor, and this is slightly different now because the argument's a little different. So just a small change. Uh, and then let's see if we keep going here. Uh, we have something that's actually brand new now, the cell units. But the cell units is just going to be a very simple mathematical operation. So I wouldn't say that this requires any new skills from last assignment. So if you're able to do the last assignment, you're able to do everything here in orange. No problem. The toString is literally like exactly the same, but you're gonna have to change some stuff. So like you're gonna have to change the actual printing. So I'm gonna say like this is like basically the same, but like small change again. Okay. All right. And that's pretty much going to be the same thing for all of those other classes, except for the electronic store class. Pretty much nothing else is going to change that much, that radically. If we do the same idea here, and I'll go a little faster for this one. It's, we have wattages. Um, well, actually, wattages wasn't a thing before. Okay, so that's new. Yeah, wattages is new. Color is old. Uh, brand is new. Has freezer is old, and then the rest of the stuff is new. Yep. And then for just for consistency, I'll make this the same. And then for the behavior, this is a small change here, right? Again, a small change. Okay. And then again, another small change here as well, because now we have a toString, and the toString, the only thing that's going to be different is you're probably going to be printing out those new variables. All right, so print these. Right. I think you have to print all of them, right? Yeah, including each attribute here. Right. So that's all of them. All right, cool. And then a cell units is going to be new, but it's going to require the same skills as assignment one, right? Because you're just going to be changing some variables here. So nothing new there. Right. So that's that. Um, so now, taking a look at the laptop, again, same kind of thing. All right, so same type of variables here. So CPU speed is old, I think. So is the RAM, the SSD, uh, store. Actually, some of these are exactly the same, right? So let's see. From the laptop we had the same being the RAM is the same, the CPU speed is going to be the same, the SSD is the same, the storage is the same, so is this the screen size, same idea, and we have some new variables here. Okay, and then we have to make a small change in the constructor, small change in toString, and this is around the same. All right, and these are small changes. Okay, all right, and for the oven class, we're gonna notice this is pretty much all gonna be new, right? So all new. All right, but it's gonna use, generally speaking, the same skills as before, and we're gonna see here that we're gonna have all of these are new, and these are just old skills that you need. So everything here in orange is pretty much the same as going to be the same as last. Now let's talk about some of the new skills you'll actually need. Okay, so if we take a look at the actual instructions here, right? Your professor wants you to do. Let's see. So you're going to the most important parts for you to remember is right around here. So your professor says you will need to add more classes. Oops. You'll need to add more classes to define the best hierarchy. Look for shared behavior between different classes to define a parent class. Note that you will not need to implement all of these if you make proper use of inheritance. So yeah, so here's where your professor is going to start talking about inheritance and such. All right, so here we have some inheritance as well. Um, and basically what they're talking about here is mostly inheritance up here. So when they say shared behavior, usually talking about inheritance there as well. Proper encapsulation is then talked about a little bit, um, meaning it should be private and not just unless you can justify them being protected. Justify them. Um, Otherwise, you should be completing the assignment without creating any public protected variables, which we'll talk more about in a bit. Um, and here the professor also talks about polymorphism. Now, the polymorphism um, also, when they're talking about shared behavior, also kind of talking a little bit about polymorphism. Okay, so, and we'll take a look at those, but mostly where is this going to apply? Well, the inheritance is probably going to apply to your desktop classes, meaning your other basic classes here. So your desktop, your fridge, your oven, um, and your laptop, right? So your professor saying, hey, like please make sure that you are using inheritance here to define these smaller classes, right? And you'll see that you have a lot of opportunities to do so, right? For example, you have like, for example, I'll give you one example here. You have your price, right? Here your price is in your desktop. Here your price is in your fridge. Here it's in your laptop. And here it's in your oven, right? So if this variable is shared across all four of them, you'll probably want to use inheritance, and we'll take a look at why in a second. All right, but it's usually to set up this polymorphism idea that your professor has introduced here. All right, and also for the shared behavior and such. All right. Okay, cool. So if there's any questions, you guys let me know, and I'll just take a look. But I'll just move on for now. So the electronic store class, um, well, making a variable is not too bad. All right, this is just make a normal variable. Skills you should already know how to do. A string, again, something you should already know how to do. A double, um, and an array of electronic store products. Now this is actually going to be polymorphism here, right? Because your professor here, and we'll take a look at an example in a second, but your professor here is saying, hey, I want you to make an array of to hold all of your electronic store products, right? So if you're gonna have but all of these electronic store products are different type of classes, right? We have a desktop, right? We have a laptop, we have a fridge, we have an oven, right? So how could you possibly put all of these different types of uh, objects into the same array, right? This would be impossible to do without polymorphism, right? So this is going to require polymorphism. This is step number 4, which we'll take a look at an example. All right, so next question is going to be a constructor. You should know how to do that already from last assignment. A get name, you should know how to do that already. Now, let's take a look at print stock. This is exactly the same as last time, right? So this is like similar to last time. Right? This is similar to last time. Get revenue is, I guess you could say that's encapsulation because your revenue is going to be private, right? So this is going to be likely to be private, right? And so we need a getter, right? And then here you can notice your professor is making you create this getter, right? In behavior step 6. Right? So that's over here, right? That's what your get revenue is going to be, right? Just a getter for your private variable there. So that's encapsulation there, basically, right? The idea that you have public and private variables, right? And then so then we have a add product, a sell product, and then a sell products that's slightly different. All right. So your add is just going to be, I would say this is kind of like polymorphism, right? So you're gonna have to know how to use polymorphism for this one, right? This is again because you're adding a product. Notice here, your professor gave you a hint, right? Look, this is a hint here. I want you to notice this. This is a hint, right? Your professor never said, hey, make a product class, right? But your professor did give you a function that refers to a product object, right? So clearly you have to make this. This is a hint, right? Right? This is a hint that you probably have to make a class called product, right? And the reason I'm saying that this behavior step is going to require you to know polymorphism is because here you're taking this function is supposed to work for any type of product, right? So I should be able to call add product on a desktop, right? Or on a fridge, or on a laptop, or on an oven, right? Like I should be able to pass it in probably, right, to this function here, right? And in order for that to happen, there would have to be some sort of polymorphism going on because here I have a product, but in reality I have a desktop, right? This is polymorphism, right? If we're gonna pretend that desktop is a product, and right, because desktop is a child product, right? That's polymorphism, right? So you need to know polymorphism to this question. Okay, we'll take a look at that. And then for your cell products, you're going to, well, cell products here is basically a derivation of this one. So if you take a look at this one first, at number 5, you'll understand number 4 better. So if you take a look at number 5, you're going to have an array where all your products are going to be, right? So like, you know, you have your products here, right? And you have an array here, right? You might have the first index is desktop 1. And you might have your next index is laptop 1. And then you might have your third index is desktop 2. And then you might have your other index be oven 1, and so on. Right? Firstly, notice that this array of products has different types of products in it, right? Like it has desktops, laptops, and ovens. And these are all, right, different types of objects, right? So in order for me to be able to put them all in one array, I need all of them to have a shared parent, right? They all need to have an ancestor, right? And because this is an array of products, their shared ancestors, the ancestor is probably going to be called product, right? So this is why I was saying this is probably a hint for you here, right? All right. So if you have an array, so let's explain this question. If I have an array of products holding some desktops, some laptops, some ovens, right? The idea is I can give you exactly 2 numbers, and I can make a purchase with with those 2 numbers, right? The first number will be the index of the array, right? So for example, maybe I'll go, you know, item here. There's 2 arguments, right? Item and the amount, right? Those are the 2 arguments passed into this function, right? So perhaps my item is 3 and the amount is 50, right? So that means I'll go to index 0, 1, 2, 3 here, right? This is index 3, right? So this is index 3, right? And then I will, you know, subtract the amount here. So if I should sell the amount of units if you look at the instructions, we should sell the amount of units of the product stored at index item in the products array if possible. Okay, so keep in mind, right, that you might have like, you know, your oven here. Your oven's right here, right, in this index, index 3. Right, so you go to this oven here. It takes you all the way down to this oven, right? And you'll notice that your oven has a quantity, right? Right, it has a quantity and it even has a price, right? So if I tell you, okay, give me 4 ovens, right? And you know that I have, oh, my quantity is 50, you know, and I sell them at $10 each, right? That means I have enough quantity because you only want 5 and there's 50 here. And they cost $10 each, so that'll be 50 bucks, right? That's what you're supposed to figure out with the function, right? So you take your index, like 3, you go here, you see, oh, it's an oven here. Okay, cool. Well, I need to buy like 50 ovens or whatever. I'm going to go to this oven object and say, hey, can I buy 50 ovens? How much is that, by the way? All right, you're going to calculate that, right? And then you're going to calculate as well if this is even valid, right? Like if 50 is allowed here, like if that's too much or not. You're not going to, if it's too much, you're not going to do the transaction, right? If they say, but I want to buy 50, but actually only have 5, then we just say, okay, you're not going to buy any, like no sale, right? So as long as you have the right amount of ovens, and as long as Yeah, as long as you have the right amount, you can buy it. So go ahead, go to this oven, subtract the amount that you just bought, right? And return the price for all of those, right? So if it's $10 each and you bought four, it's be $40, right? So, um, and then so you're doing that. Um, that's what sell unit is going to hopefully do, right? So you go to your array, you find your oven, right? Based on that index, and then you say, okay, I want to buy this many ovens, right? So you're going to call this function sell units, right? To see if you know you can sell it. Um, so if this is successful, right? If sell units is successful and you manage to sell your 5 ovens or whatever, because there's a maximum of 50, then this function will return the price for those 5 units you just bought, right? You'll come all the way back up here and you'll say, okay, cool. According to my individual object, I'm allowed to buy that because they returned a value that was like greater than 0. So I'm going to return a Boolean now, right? I'm going to return a true or false, right? True if the sale went through, false if the sale didn't go through, right? So just to recap, I go to my store and I say, hey store, I want to buy item at position 3 and I want to buy 50 of them. Another way you could think about it is if you went to the store and you said, hey, I know you guys have a unique item code for every item. I want to buy item 4168 and I want to buy 30 of them, right? So then the store would go to their list of items, go to the to item number 414, whatever number you said, say, okay, according to my list, I have 50 of these, and oh, you want 30 of them? Okay, cool. That transaction is possible. I'll go right. I'll calculate how much that is, right? And then I'll return a true value because I know I can sell it to you. If I couldn't sell it to you, I would return back a false. All right. So now, one thing that you may notice about this, okay, is I'm starting out here with an array of products, right? And I need to be able to go to a product and tell the product, hey, I want to buy a certain amount from you, right? Or I want to be able to call sell units, right? So I can buy a certain amount of units, right? But inside of my actual array, I only have desktops, laptops, and ovens, right? So, but they all need to be able to sell you something, right? Because they all need to be able to tell you how much it would cost, right? The transaction. Depending on whether it was a laptop or a desktop or an oven, it doesn't matter. You still need to be able to calculate how much that purchase is going to be, regardless of what type of product it is, right? Which kind of tells you that all of the products in this array have to have the ability to sell something, right? They all have to have this function, right? They all have to have sell units, right? If all of them have it, right, then I can go ahead and write this function, right, knowing that every single element in the array will be able to do this, right? And to do that, in order to make sure that this actually happens, you probably have to use polymorphism and inheritance again, right? Because you need every single element in the array to have this function, right? You need all of them to be able to sell you something, right? A desktop needs to be able to sell something, a laptop needs to be able to sell something, an oven needs to be able to sell something, right? They all have to have shared behavior, right? If you want to do this easily and effectively, you should probably use polymorphism and inheritance. There's technically always a way to go around it, but this assignment tells you to do it. You're going to lose marks if you don't. All right. So okay, great. So this is probably going to take some inheritance and some polymorphism, or knowledge of it, I would say. Right. So So you need like inheritance, and you need polymorphism, right? Which means if you need it for here, then down here, right, you're probably going to need to inherit here. You're probably going to need to do it for all of these as well. This probably has to be an inheritance thing. Right? Okay, great. Um, now, I don't. That's not the only. This is not an exhaustive list. So there's definitely going to be other places where you're going to need inheritance and polymorphism probably, but definitely you need it for this question, right? And if you need it for this question, you're going to need it for this other question because these two questions are the same basically. Okay. So the only difference between this one and whoops, the only difference between this one and this one is that for this question you're going to get two arguments, and for this question you get no arguments. Okay. Now for the question that you get no arguments, you're supposed to just create the two arguments that you need, right? And the way you're going to create them is by actually asking the user to enter it in with their keyboard, right? So this function here, you take the two arguments and you run the function. But this one here, you don't get the two arguments, but you find them out yourself. You grab them yourself, right? Using the keyboard input listener thing that we used last time, right? Remember the scanner? You can use that again here to grab the two numbers you need. All right, so if it says read an integer for representing the product to sell, and then it says read an integer here for representing the number of units. All right, so this can be done using a scanner. Right, and then right, you can probably just call this function here. Right, don't duplicate your work. Right. Okay, cool. Great. Does anyone have any questions about the specs before we move on to some examples? All right, so let's take a look at. Uh, Firstly, I want to give you some encapsulation advice before we move on to inheritance and polymorphism. Encapsulation is basically, like one thing I would recommend for you guys to do is don't let encapsulation be the thing that stops you from doing this assignment, okay? Because it's actually it's a lot easier than you may give it credit, okay? So don't let this thing like slow you down at all, okay? If you don't know how to do encapsulation right away, but you want to start working on the other stuff, just make everything public at first, and then just go back and make it all private. You don't need to seriously refactor your code in order to make stuff like that work. Okay, and that's because it's very simple to do encapsulation, right? So whenever you have an equals, you got to replace it with a set, and whenever you just use the variable, you got to replace that with a get. All right, so if I have, so you need to replace every time you see something like object dot myvar equals x. Okay, so whenever you see that, replace that with object dot set myvar, and then you pass in x. This is pretty much going to be the formula you're going to use, right? So for every variable you have, just make a setter function for it, right? And then just call the setter function and pass the value. Okay. Now that's for whenever you're using an equal sign, right? When you're using when you're actually just referring to the variable, right? You're gonna do another type of replacement. So whenever you have something like system.out.println, object dot my variable, just go ahead and replace that with a getter call. So we say get my variable. And actually, fun fact, when you're using IntelliJ, you can actually have all of your variables automatically be turned into public ones, or in private, and vice versa. You can have IntelliJ automatically generate getters for you and stuff, and call them for you, and stuff. You may want to look at the refactoring options, where you can just a lot of the time you can just right click on a variable that you want to make private, and you can start going ahead and it'll start generating stuff for you. Okay. All right, great. So let's move on now. All right. And let's take a look at some examples of inheritance and polymorphism. Okay. All right. So let's take a look at this example here. All right. Is everyone able to see this? Someone let me know in chat. Oh, there's a chat here. Oh, I didn't know this. Sorry. There's questions here. My bad. I didn't realize that there's a separate chat for each voice thing. That's my bad. Okay, I'll go from the top. Okay, everyone says you can see it. Cool. Yes, that could work. Oh, sorry. This is from last assignment workshop. For the final variable, what does it mean to change the number of products when it's changed? Isn't it final? Oh, that's a good question. So here, I know what you mean. So you mean over here. Let me just pull that up. You mean here, right? So, because you say this value here should be, or the code should refer to this variable so that it can be changed by changing the value. This is the part you mean, right? The part you have a question about? The fact that it says you can change it here, but it shouldn't be changed, right? So, yes, what this means is this, okay? So, whenever you make an array, you need to give the array a size, right? So, I can make it by default here 10. All right, so every time I make an array, I always make 10 things, right? So, but what if I wanted to change it to 20, right? Now, keep in mind, right, that when I'm actually running the code, when the code is actually running, I'm not going to change that value from like 10 to 20, right? Because I don't care, like, I might not, because I don't, the question isn't asking you to have the ability of changing this value from 10 to 20 mid program, like while it's already running. That's not what it's asking you to do. It's asking you to be able to change this at compile time, right? So before the code runs, if I decide I want to change the size of my arrays from 10 to 20, then before the code runs, before compile time, I can go into the code and change the code itself so that instead of it saying 20 or 10, it says 20. And now I have arrays of size 10. Now, the reason that your professor is being like very explicit about this and telling you to make a variable called max products is because what your professor doesn't want you to do is for you to hard code every single array as being size 10, right? Because if you go ahead and you have like 10 arrays in your solution, right? And every single time you have an array, you hard code the value like 10, like by typing in 10 on your computer. Then, if you wanted to change the size of your arrays, pre-compilation, before you compile, right? You'd have to go and change every time you set a 10 to a 20, right? So the reason your professor is saying, hey, make one variable for the size of your array called max products is so that like if you wanted to change the size of all of your arrays all at once before it compiles, You just change the value of this one variable from 10 to 20. And because you've based your sizes of your arrays based on this variable, all of those arrays are going to change their size after you change it, right? But this will only be in compile time, like pre-compile time, not while the code is actually running, right? When the code is actually running, you don't want the value of max products to change because you want all the arrays to be one size. So you don't want this to ever be able to change to 20. You don't want somebody to be able to go into that and hack your code, change that to 20, and all of a sudden none of your code works. It all crashes now, right? So this is just like for compile time. Does that make sense? Uh, so if the size is changed, then we should manually add products corresponding to the new size. Well, not manually, automatically, right? Because you've gone every for loop that loops through an array, you're gonna be basing that off the variable, right? Every time you create an array, you're gonna be basing that off the variable, right? Every time you modify the array, right? Even if you were to make a new copy of an array and make it the same size as the old one, you're not going to hard code the value 10 in any of these places. You're going to refer to this variable here, right? That is equal to 10. Does that make sense? Okay, cool. All right, so let's move on. Uh, okay, so here I'm going to describe an example that would be very easy to solve using polymorphism and very hard to solve without polymorphism. Hopefully you'll see how this is similar to your assignment and this will help you. All right, I'm going to give you this as a one-to-one example you can draw on, and I'm going to give you the code for this as well. All right, so let's take a look at this example. All right, we have a game that we're trying to make. Okay, and the game is going to have a party of adventurers. All right. Now the different adventurers can be different types of adventurers, right? So for example, we have a wizard, we have a healer, and we have a fighter, right? Now if you take a look at them, they're all fairly similar. I mean, they have a name, they have a health, and they have a power value, right? And they all do, right? And they also all have one function, right? They all can perform they can all do a move, right? So the wizard can perform a wizard turn, the healer can perform a healer turn, and the fighter can perform a fighter turn, right? Very simple game, right? And we have a game engine, right? So this is our object called game, and it's going to just be quote unquote the game engine, okay? Now, I haven't actually coded this because it's not important for the example, right? So here we actually don't have anything coded inside of the wizard turn, but just assume that this function has a bunch of stuff that the wizard does every turn, right? And just assume that the healer has a bunch of stuff here that they do every turn, and that the fighter does something every turn and stuff, right? If we had this game, this theoretical game, it would also have a theoretical perform all turns function, where the game would have the wizard do his turn, then the healer do his turn, then the fighter do his turn, then the next healer does his turn, then the next wizard does his turn, and so on and so forth. Everyone gets to do their turn, right? Again, we haven't written this. We're going to assume it's there, okay? Now we're going to see some problems instantaneously with this, okay? So the first problem is this, okay? I make the game engine. That's all cool. I make a wizard, right, by giving it the name Harry Potter, some health 75, and some power, right? I make two wizards. I make a healer and a fighter. And that's my party of adventurers, right? I have 4 adventurers here, 2 wizards, a healer, and a fighter, okay? First problem that we would have, okay? And this is a problem you would have pretty much in any scenario you would have a game. And you could have this scenario be in other things that aren't games. Like you could have this be a problem for like a word processing application you're making, where you have your engine and then your engine has a bunch of smaller components to it, right? In this case, our engine is a game engine, and we have smaller classes that are components of that game engine, such as the wizard or the healer or the fighter or so on, right? But this could be applied to pretty much any scenario where you're coding something where there's certain types of elements, right? We have the game engine and it has other smaller, or the main engine and it has other smaller components in it. So in the very first problem we're going to run into when we have a setup like this is this. How do we save all of the party members into the game engine? Okay. Now we're going to go ahead and we're going to code up two different solutions. One solution that the only one that you could possibly do if you didn't know anything about polymorphism, and it's going to be a pretty horrible solution, and we're going to see why. And then we're going to code it with polymorphism and see what the difference is. All right. So first question, right? We have all of these adventurers. How do we get them all into the engine? Because the engine is going to have to be able to refer to all of them. Okay. Now, let's see what the problem here is. Okay. The problem, right, when we're actually trying to save this into the game engine, is that they're all different types of objects. Right? We have wizards and healers and fighters. Right? So if we wanted to actually store all of them in the game object, right, without polymorphism or anything like that, we would have to make an array of wizards and an array of healers and an array of fighters. Because if for this scenario, right, we have to assume that you could have any combination of this, right? Because this is my party, but maybe your party will have 2 healers and 2 fighters and 1 wizard or some other combination. We don't know. So we have to have, and because they're all different objects, different types of objects, we would have to put them all in different types of arrays. So okay, let's do that and let's see what that looks like. So here we have our naive solution, okay, and we're gonna solve it using that naive solution. All right, so here in our game, you can go ahead and make 3 types of arrays: a wizard array, a healer array, and a fighter array. Right? Then, what I would have to do is go ahead and initialize those every time, right? So new wizard array, let's say we can have a maximum of 10 wizards or something like that. And then we could have our healers, which is a healer array, and then our fighter array, which is a fighter array, right? And we can then populate each array. So we can say game engine dot wizards at position 0 equals our first wizard. Our game engine at wizards position 1 is our second wizard. And then, so those are our wizards. And then for our healers, we'd have to do the same thing again. Position 0 equals our healer. And then we grab our fighters. We put the fighter in the first position of the array. There you go. We've solved problem 1. Okay? So, doable, but already it's kind of a pain, right? And again, think about what would happen if you had to add more healers, or sorry, a different type of adventurer. Like what if you all of a sudden had to add a rogue in, right? How much work would that be? You have to like define a new type of array and initialize it and then put it in the array, right? Okay, but it's still doable, right? Cool. So how would we do this if we were doing polymorphism? All right. So this would be like the smarter solution. Okay. So, okay, let's take a look at the problem. Again, the problem is we're trying to save all of these components into our game engine, right? But we can't do that easily because all of the different objects are different types, right? So what if they were all the same type somehow? Then we could put them all in the same array, right? Right? But if they were all the same type, then they wouldn't have the abilities of a wizard, or the abilities of a healer, or the abilities of a fighter. So we would have to have some sort of in-between way of being able to refer to all of them as the same object while in reality, treating them all like a wizard or a healer or a fighter. Well, we can do that with polymorphism. Okay? Polymorphism is that exact idea. We're going to refer to all of these generically as an adventurer, but in RAM, they'll still be a wizard or a healer or a fighter, so they'll behave the way they're supposed to, but we can refer to them generically. That's what polymorphism is. So let's give ourselves an example, okay? We have the wizard, the healer, and the fighter. It would be nice if we could refer to them generically as an adventurer, because then we could have one array of adventurers and put all of them in it. Okay, so what if wizard, healer, and fighter were all had a common ancestor called adventurer? Then we could use polymorphism to do this. Let me give you an example. So we first create a common ancestor for these classes. Let's call it adventurer. All right, and that's all we do. Then we go to each child and make sure that it is a child of adventurer. Right? So now all wizards are adventurers. Right? Now all healers are adventurers. Now all fighters are adventurers. Right? And we can go ahead and make this class abstract. Right? Because we're never going to actually have an adventurer. We're going to have a wizard or a healer or a fighter. Right? So the word abstract here means, hey, I don't ever want a generic adventurer. Right? I don't ever want you to be able to use the new keyword on the adventurer class. I just want to be able to make children of adventurers. So I'm going to make this class abstract so I can only have concrete children, but I can't have a generic adventurer. I can have an array of adventurers, but I can't make an actual adventurer. I still can't say adventurer, my adventurer equals new adventurer. He's already getting mad at me. Right? This is invalid because it's an abstract class, meaning I am not allowed to use the new keyword. That's what it means to be abstract. You're not allowed to use the new keyword, right? And this is a good thing because I'm creating an ancestor for my wizard, my healers, and my fighters, so I can refer to them as adventurers. But I don't actually want a generic adventurer. I want a wizard or a healer or a fighter. I don't want some generic adventurer who can't do any magic, who can't do any healing, and who can't swing any swords. I want someone who's an actual adventurer, but I want to be able to refer to my adventurers as adventurers. So I make the class abstract, right? So that I can't use the new keyword on it, right? Which means if I have an adventurer, it has to be a wizard. It has to be a healer. It has to be a fighter. It has to be something that's not a literal adventurer. It has to be a child of one of the adventurers, because a literal adventurer is abstract, and I can't call new on it. So if I have an adventurer, I know it's a wizard or a healer or a fighter. I know it's not a generic adventurer, because that can't exist because I made it abstract. Right? I can't have a generic abstract adventurer because the adventurer is abstract. But the child is not abstract. Wizard is not abstract. So I can have an actual wizard using the new keyword. This works, but this won't work. And notice, actually, this would work too if I said new wizard here. Right? Why is that the case? Right? Like, why is one of these not working, one of them is? Right? It's because you're not allowed to call new on an abstract class. You're only allowed to call new on a concrete class. And we made adventure abstract, and we didn't make any of its children abstract, right? So we're allowed to call new on the children, but not on the parent. This is a good thing, right? Because we don't want a generic adventurer, because there's no such thing as a generic adventurer. Every adventurer has either magic powers, healing powers, or a sword. There's no such thing as a generic adventurer, right? The reason we created this adventure is so we could solve this problem, which we'll do now. All right, so now that we have this inheritance thing set up, we can actually refer to wizards like we did here. We can refer to a wizard as an adventurer now. Right? This my adventurer looks like an adventurer, but it's in reality in RAM it's a wizard, which means I can make an array of adventurers and put all of them in here. So I can go ahead, right? And here we had like this really ugly solution here, right? Where, a second, try to pull that up. Yeah, here we had this really ugly solution in a naive solution where we had to define an array for each type, right? Each type of adventurer. But now that we have a shared ancestor between all of these classes, we can refer to them generically. So we can go ahead and say, sorry, that's the wrong one. We can go ahead and say, give me an array of adventurers, right? I'm going to call it the party, right? And then I can go ahead and initialize that. So I say GameEngine.party equals new adventurer. Now, I did say you couldn't use a new keyword on adventurer, but this is not using the new keyword on adventurer. This is using the new keyword on adventurer array. Now, an array of something is a completely different data type as that thing. An array of integers is a completely different data type from an integer, right? An array of strings is completely different than an actual string. An adventurer is completely different than an array of adventurers. So I can't use the new keyword on a single adventurer, but I can use a new keyword on an array of adventurers because each adventurer here by default is null, right? None of them are, so I didn't actually call new on a single individual adventurer. They're all null right now, right? Okay, cool. So here I have my array, and now I can start filling it up. So I put in the first index, I put my wizard, right? My second index, I put my other wizard. Oh, whoops. My third index, I put my healer. My next index, I put a fighter, right? And so on. Right? This is polymorphism. I'm referring to a adventurer generically. But in reality, in RAM, I have a wizard. That's polymorphism, right? Generically, I'm referring to it, but in reality, I have something like different in there, like a wizard. That's polymorphism, right? I'm generically referring to it, but in reality, it's actually different, like what it is in RAM. It's not actually an adventurer, it's a wizard, right? That's polymorphism. Okay, so here, that's how you would solve problem 1. Any questions? All right, cool. So let's move on. Here I have a same problem, okay? Slightly higher tier of how complicated this is. So now, let's consider the healer for a second, okay? Whenever the healer makes a turn, it's going to heal the other members of its party. What that means is it's going to increase its health value by some amount. Okay? And for this, we'll just say maybe it increases it by the amount that they have defined in their power. Right? So, okay, how would I do this? Right? So I need to go to every single type, like I need to go to a wizard and I need to be able to increase its wizard health. And I need to be able to go to a fighter and increase its fighter health. And I need to be able to go to other healers in my party, and increase their healer health. Right? Okay. How could we do this? Well, we could solve this problem using polymorphism, which would be a nice elegant solution. Or we could have a naive solution where we don't use polymorphism. Let's see what those two look like. Okay? So if I was going to solve this without using polymorphism, how would I have to do this? Okay. Well, firstly, I would have to look at every single person in my group, right? In my party, right? So the game engine is already holding that, so I could just do that, go through the game engine, right? And the game engine has an array of wizards and an array of healers and an array of fighters. So I could loop through this array and then this array and then this array, right? When I'm at a wizard, right? If I am currently at a wizard, right? Then I'll grab the wizard health value and I'll subtract that. Oh, sorry, and I'll add, because I'm healing them, I'll add some amount, right? Maybe our healer power. Okay, then I'll go through and I'll grab the next array, right? I'll go to the array of healers, right? And I'll go through every single element there, right? And I'll increase their health, their healer health. Then I'll go back to the game and I'll go through this array of fighters. I'll loop through that array of fighters, and for every fighter, I'll grab their fighter health and I'll increase it. Okay, so let's write what that would look like. So I would loop through the first thing, right? So for int I equals 0, so once I is less than the game engine's healers. And here I'm just going to go ahead and make the size of the array equal to how many wizards we have, how many healers we have, how many fighters we have. Okay, so if I grab the healers, grab the length, that gives me how many healers I have. And I'm going to loop once for each healer we have. Oh, sorry, we should probably start with wizards. Okay, then I can go ahead, grab that wizard at my current position, and I could grab their wizard health, and I could increase it by, let's say, my healing power, right? So this heals all wizards by my healer power. Okay? Now I could go ahead and do this for all the types we have. So for all wizards, for all healers, now I have to change this part here to healer health. Okay, and then I could do this again and do this for fighters. Oh, this shouldn't be power. This should be fighter health, right? Or healer health. And this should be fighter health. Okay, so I've gone ahead and I've healed all the wizards, all the healers, and all the fighters. Okay, now this solution. What's the problem with this solution, right? Well, what if we need to add a new class like rogue? Okay, well now to add rogue, we have to go back to problem 1, right? Add a new type of array to the game, initialize that, put the stuff in there, and then we need to add a brand new for loop, and then refer to the rogue health. Okay, seems like a lot of work. Let's take a look at what we would do for polymorphism. Okay, so if we take a look at what we would do for polymorphism, we need to ask ourselves a different type of question, right? So what is the problem here, right? The problem with the old solution, right, is you had to copy paste a bunch of for loops to do this, right? Why do you have to copy paste a bunch of for loops? Well, it's because I have 3 different types of arrays for my 3 different types of healers, right? That's the first problem. The second problem is their health values have a different name. They're called a wizard health and a healer health and a fighter health. That's not helpful, right? These are all the same thing. These are all health. Why should we have different types of variables for all of them? That doesn't make any sense. That combined with the fact that we have to have a for loop for each different type of array means we have to add more work every time we add a rogue to this healer, right? Our code is not at all dynamic, right? It is because we're not being generic enough, right? So let's use polymorphism instead. Okay, what if our wizard, our healer, and our fighter all had a shared ancestor called adventurer, right? And this adventurer had health, right? Then we could remove the wizard health, the healer health, and the fighter health. And we could refer to it generically using polymorphism, right? So I'm going to go ahead and I'm going to do that. So in my adventure, I'm going to define an integer called health, right? And I'm going to go ahead and remove that health variable from the wizard, from the healer, and from the fighter. And actually, just so that I can have this look a little bit more clear, I'll just actually comment this out. And then here, just comment this out as well. All right, so now we've gotten rid of each individual type of health, but now we have a more generic health, right? So now, if we go back to our healer example, okay, well, we've solved both problems now because we don't have to have one for loop for each type of adventurer anymore. We could have one for loop to loop through the one array of adventurers we have. Right? And now we've solved the other problem too, because we don't have to refer to it specifically as a wizard health, and specifically as a healer health, and specifically as a fighter health. Now, because of inheritance and polymorphism, we can actually refer to their health generically. Right? So what would that look like? Well, I'd loop through my adventurers. And then here we could have, we grab our current adventurer, and we grab their health, we plus equal it with our healing power, like this, right? Okay, and that's the whole solution, right? And think about this: if I add a rogue now, what do I have to do? Well, I'll just have to add it to the array, and then that's it. As long as the rogue was a child of adventurer and it had health too, it was extending it, this would just work instantaneously. Right? Cool. And by the way, we should have this array referred to 4 because there's 4 adventurers exactly in here. Oh, look at this. All of this breaks now. That's interesting. So we could actually go ahead and make sure that this works now, because this is just health. Right? All right. Cool. All right, so that's how we would solve that problem. All right, so now let's take a look at the third problem here. Okay, so now let's take a look at this so now we've taken a look at it from the perspective, the polymorphism perspective, for when you're outside of all the classes involved here, right? And then now we've looked at it from the perspective of if you're like the inner class, like wizard. But now let's look at it from the perspective of game. Okay, so if we have this problem here, we know that the wizard, the healer, and the fighter all can take a turn, right? So the game should have a function that lets everyone make their turns, right? So the game starts, it's set, you call, okay, let's perform all of our actions, and then the game goes, okay, I'm going to go to my wizard and perform their wizard action. And I'm going to go to the healer, and I'm going to perform their healer action. And then I'm going to go to the second wizard and do their wizard action. And then I'm going to go back to the fighter, I'm going to do their fighter action, right? So in this function, because it's the game engine, I should be able to perform all of the other turns, right? So how would this happen, right? And by the way, I want to make sure that you understand that this could be an example that would work for things that weren't a game, right? Because this could be an engine, and your engine could have multiple components in it, right? And you could have a function here called update or something like that that makes all of your components do something every frame, for example. Regardless, let's say we had we wanted this function to have it call perform wizard and perform healer and perform fighter turn for all of these. Okay. Now, let's think about the naive way of solving this without polymorphism. Okay. So let's solve that. So okay, what would I do without polymorphism? Okay, well, I have an array for my wizards, an array for my healers, an array for my fighters, and a wizard has a wizard turn, and a healer has a healer turn, and a fighter has a fighter turn. So I guess I would just loop through the wizard array and call perform wizard turn on every wizard, then go through the healer array and call perform healer turn on every healer, go to the fighter array and call perform fighter turn on every single one, right? So I could go ahead and do that. So I could go, and it'd be a very similar solution to this. Okay, so I would come over here, and instead of healing, is perform all wizards' turn. Okay, great. And here it wouldn't be, you don't have to refer to that, just say wizards, or just say the array. Okay, so here, instead of calling this, I would say wizards at position I, my current wizard, so I'm looping through all the wizards, and I'm going to say, okay, perform your turn, right? And then I'm going to say, okay, healer, perform your healer turn. And then I'm going to say, okay, fighter, perform your fighter turn, right? So this would work. But then, right, what's the problem with this? What if I want to make another class like rogue? Okay, now I'm going to have to make another for loop so I can loop through the rogue array. And then I'm going to have to specifically call perform rogue, not just perform something else, perform rogue turn on that thing. Okay? And that would not be super scalable. What if I had like 30 classes or something? That's not great. What about polymorphism? Well, this is actually another super simple solution to doing polymorphism. Because if I can refer to okay, well let's take a moment to take a look at the problem here, right? I have a wizard turn, a healer turn, and a fighter turn, but they're all like a turn, right? They're all like they're all making a turn, but they all have a different name, like a wizard turn and a healer turn and a fighter turn. So it'd be nice if they all had a shared ancestor, maybe call it, I don't know, adventurer, and this shared ancestor had a function called perform turn that was abstract, like generic, right? Then, when I have an adventurer, I could refer to perform turn generically. Instead of a perform wizard turn and a perform healer turn and a perform fighter turn, I can refer to you taking a turn generically. I could say, hey, adventurer, take a turn, right? So how would I do that? I would come here, and I'd go ahead and I'd define that function. So public void perform turn, and I would make this function abstract, right? Why would I make it abstract, right? I'll explain in a second. So we have our wizard here. We're going to rename this. Oh, and this needs to also take an argument. So I could come in here, and now I can rename this from perform wizard turn to just perform. All right, sorry about that. My mic cut out there. So, all right. So if I have this adventurer here, and I have this perform turn, this function is generic, and I didn't even define what it does. Like there's no curly bracket here, right? I didn't tell it what to do, right? So just like you can't call new on adventurer because adventurers, you know, are not instantiable. You can't call new on an adventurer because it's not fully defined either, right? Um, your function here isn't meant to be fully defined, right? It's supposed to be a generic placeholder, right? Now, I can call perform turn on any adventurer, but when I call perform turn, the only functions that are actually going to be called are actual perform turn functions. You can't call this thing because there's no curly bracket here. It's missing curly brackets. You can't actually call this function from within the adventurer. The only functions you can actually call that are called perform turn are in the wizard, are in the healer, which we'll put in a second now. So we can just go ahead and do this. Go ahead and do that. The actual perform turn implementations are in a wizard, a healer, and a fighter. And again, don't forget, an adventurer can only be a wizard, a healer, a fighter. Yes, you can have a generic variable that is of type adventurer, but you can't call new on adventurer. So if you have a variable that is an adventurer, you know it's a wizard or a healer or a fighter, and you know that a wizard, a healer, and a fighter are all going to have a perform turn that's actually defined. So whenever you call perform turn on an adventurer, you know someone's going to actually call a real perform turn function for you. That's polymorphism, right? So how would I do that? I would loop through all my adventurers. So loop through all my adventurers, and for each one, just call perform turn. Right? That's it. Right? And so what's the advantage with this solution? Oh, this shouldn't be 0, this should be I. So what's the advantage of this solution compared to the naive solution? Well, there's many advantages, right? Many advantages. So we don't have to make a for loop for each type of object. Right? That's nice. We also don't have to find what the name of their perform thing is. Right? Like we don't have to write perform wizard, perform healer, perform fighter, whatever. We just write perform turn. We know that they're going to have a perform turn because we defined a common ancestor that has an abstract function of this, right? So when we have an actual adventurer, we know that they're going to have a perform turn. Why is that? Because when we have an array of adventurers, like we do in our party here, yes, we have an array of technically we have an array of generic adventurers, but we don't actually have an array of generic adventurers, because if you look at each single index in our array of adventurers, they're going to be a wizard or a healer or a fighter, a real implementation of that abstract class, a real concrete class, a non-abstract class is going to be in every single element. And we know that those concrete classes have to have a perform turn function. In fact, it would be invalid. If I went in here and I comment this out, this wouldn't work all of a sudden. This would crash. Why is that? Because I have a concrete class wizard that is extending from an abstract class adventurer, right? Adventurer has an abstract function called perform turn. So if I don't implement my own version of perform turn, I will crash, right? Unless I make this class abstract too, right? And that's because you can't have a concrete class that has an abstract function in it. It doesn't make any sense, right? Our adventurer has an abstract function in it, right? But that doesn't make a lot of sense, because you can't have an adventurer that does nothing on their turn. Just like you can't have an adventurer who isn't a magical user or a healing user or a sword user, right? Because this one's abstract and these are non-abstract, right? These are non-abstract, right? So you can't have a generic adventurer. You also can't have a generic adventurer who has a generic perform turn function, because this function is abstract, it's generic, and it doesn't have curly brackets. It doesn't have a definition. So you can't have an object with that has a function and that function has nothing. That doesn't make any sense, right? So this is abstract, right? This class is abstract. When we have a child like wizard inherit from it, it needs to, if it wants to lose its abstractness, it needs to go ahead and implement perform turn. If it will not lose, it will not lose its abstractness. It won't let you make this a concrete class without this, right? That's because you need an implementation for it. You didn't have an implementation in Adventurer, so now you have to have it in the concrete child. Because again, I can make a wizard, and I can say, "Hey, wizard," right? I can go ahead, and I can say, "I'm gonna make a wizard," and I can make a new wizard, and I can go ahead and say, "My wizard dot perform turn." Now we know that like the compiler knows that this is possible. Why? Because wizards have a defined perform turn, right? But if I do this with an adventurer, look, it's even tried to put a perform function in there for me because the notes doesn't exist. If this was valid, let's just pretend in Magical Fairyland that this is like legal. This wouldn't be legal. This part wouldn't be legal, right? Doing perform. This part wouldn't be legal. It would crash there. Even if it somehow let you do this part here, it wouldn't let you do this part. Why? Because adventurers don't have a perform turn, right? So when you have this concrete class that is inheriting from the abstract one, you have to go ahead and define what the abstract function does, because it's not defined right now, right? Then you can refer to things generically using polymorphism, right? Now my adventurer, right? My adventurer object, which is actually a wizard here in this little example, right? I have an adventurer called my adventurer. Let's say my adventurer, right? My adventurer here is an adventurer, but in reality it's a wizard. Like in RAM it's a wizard. So when I go to this adventurer and I call perform turn, I know that's going to exist because wizards do, but not just because wizards do have one, but because I know, like the compiler knows that this adventurer was created with a new keyword, and the compiler knows that the new keyword must have been used on a concrete class, not an abstract one, because if you try to do it with an abstract one, it would crash, right? And so by the time you get down to this line of code, you don't even your compiler or you or whoever is reading this, you may not know what type of adventurer you have in there. You may not know if it's actually a healer or a fighter, right? Unless you actually looked at the line above, you may not actually know what that adventurer actually is, but you know it'll have a perform turn. Why? Because this adventurer had to have been concrete in order for me to have made it in the first place, since I can't call new on an abstract one. And because I know it's concrete, I know it has to have an implementation to perform, because if it didn't, it would crash. That's what polymorphism is, right? I can now then refer to my adventurer generically. I can call perform turn generically, but I know it will actually have a definition, because any time that I used new, I had to have done it with a concrete version of the abstract one, and the concrete version has to have perform turn implemented, which means even though I have a generic reference to it, I know in reality in RAM it has to have a perform turn implemented, since I couldn't have used new on it in the first place, right? Okay, cool. So hopefully that makes sense. So that's how you solve that problem. And now you're probably starting to see that polymorphism is really useful. If I wanted to add another class like rogue, I wouldn't have to change this function at all. I don't have to change my game engine whenever I want to add a new rogue class. I don't have to change my engine at all. All I have to do is go to the launcher and say, hey launcher, like make sure you link in my rogue down here in my engine before the game starts, right? I don't actually have to change the engine at all to add a new class to the game. All I have to do is tell the launcher, hey, when you start the game, make sure you link in the new type of rogue. I don't have to actually go in and change anything here in the actual game engine, right? So now, here's problem number 4, okay? And we're not actually going to code this one. This is just something to leave you thinking on. How do you easily add a new class now, like rogue? Well, you could just do what I told you just 2 seconds ago if you had the smart solution, right? If you wanted to add a new class to your game, all you have to do is make a new child of adventurer and then link it in inside of the game launcher, right? And actually, you know what? I might as well just do that. So I could come in here and I can make rogue, and I could make this guy extend our adventurer, and then I could go ahead and implement the method I'm missing, right? And I'll just say something like the rogue sneaks up and does a sneak attack. Okay. Now I'll just tell the game. Now that okay, that's it. I'm done. Basically, I've made my new class, and now to link it into the game engine, I'll just go to the launcher and have it be linked in. And I might as well just define the rogue here. And there you go. That's it. Rogue is now in the game. And maybe I could actually, go ahead and, define this rogue, like its name and stuff, like the same way I did it up here. But whatever. It's the same idea, right? And that's pretty easy. Now, in the harder solution, or in the naive solution, how would I do this? Okay, I guess I make a new class for rogue. I also copy paste the exact same variable names basically. I go ahead and define perform rogue turn. Then I go to the game engine and I update the perform, right, to add a new for loop in there. I also go ahead and I add a new array for just rogues, and I make sure I initialize that array, and then I make sure I put the rogue in there, right? So I think everyone can see how that's a lot harder than the smart solution. Okay, so that's how you use polymorphism. Okay, now for your assignment, if we go all the way back to your assignment, you have some classes like desktop. You have like desktop. You have like your fridges. You have your laptops, your ovens, right? These can be your concrete classes, but you probably want some sort of hierarchy. You probably want a shared ancestor. And your professor gave you a hint because your professor says, oh, you have to have a function here called add product. And oh, look, they just so happen to refer to a class that they didn't tell you about. Huh, that's kind of strange. What if you had a shared ancestor called product, right? You could have a shared ancestor for your desktop, your laptops, your fridges, etc. Have a shared ancestor called product, then you can apply all of these tricks, right? You can have an array of generic products. But in reality, each individual product is a desktop or an oven or a laptop or whatever, right? You could have that product have functions in it. For example, it could have something like cell units, right? Notice that every single one of these classes has a cell function with the exact same return type and the exact same argument, right? The desktop has a cell units, right? The fridge has a cell units. The laptop has a cell units somewhere here, right? And so does the oven somewhere or whatever, right? So the fridge does, right? So they all have the exact same function. They all probably have to have a shared ancestor. that shared ancestor probably has to be product if you wanted to actually work with add product. And then if you're actually going to make a shared ancestor called product, why wouldn't it just have the shared, like why wouldn't it have cell units, for example, right? Now, there's one thing you can do, which I didn't quite note, but I will say this. You can actually define something here. So I could say something like, if I make this not abstract, an adventurer does something epic. Now I have to write some sort of really generic thing here, which doesn't really make sense for this example, right? But for your example, it might actually make sense if you sold stuff in the same way every time. I'm not exactly sure. You'd have to like take a look at it for yourself. But this is the same idea anyway. You could either make this abstract if you wanted, or you can make if you wanted to make this. If you make this abstract, right? Now you have to define perform turn in every single adventurer. If I don't make this abstract, then all of the children get this function for free, but it's still valid to go ahead and override it. Right? That means delete the old one and put this one in there, just for rogues. Right? So you could do a thing where you have in your assignment a thing where it's abstract or not. Maybe you want to take a look at that and actually decide which one makes more sense for your assignment. All right, cool. Are there any questions about the assignment before we head out? All right, cool. If you have any questions, please send me a message on Discord. My name is Manuel. You can also send me an email at manuelflebron@cmail.carleton.ca. Good luck on the assignment, everybody.